DeepVisus, Episode 2. Can a model know more than its creator? Exploring Chapter 2 of George Campis's Self-Modifying Systems in Biology and Cognitive Science, 1991. If all scientific knowledge must pass through models, then here's the question. Can models themselves be creative? Can they know more than we do? Welcome to DeepVisus, the series where we navigate the deeper layers of visionary systems thinking. In our last episode, we opened the gates of George Campis's bold 1991 book, Self-Modifying Systems in Biology and Cognitive Science. Today, we step into Chapter 2, a foundational and radical meditation on what a model really is. Reorienting the ground. What is a model, really? In this chapter, Kampis doesn't just ask how models work, he rewrites the stage they perform on. The chapter is titled A Constructive Approach to Models, and it's not about technical improvements. It's about epistemology, about how we know through building, not just describing. Traditional science treats models as mirrors, mathematical tools that passively reflect aspects of the world. But Kampis flips the metaphor. He says, models are active constructions. They produce knowledge. And like living systems, they do it by growing, shifting, and interacting with their environment. Key insight number 1, no fact without a frame. Kampis starts from a simple yet unsettling truth. There is no direct access to reality. Everything we know, particles, neurons, weather systems, emotions, is filtered through models. These models are not static, they're instruments of transformation. In his words, even empirical data, what we often treat as given, is extracted via models. He likens facts to outputs of a channel shaped by constraints, selection, and structure. Which leads us to a quiet but potent claim. Observation is not neutral, it is designed. Key insight number 2, mathematical truth versus empirical meaning. One of the strongest arguments Kampis makes is that mathematical models don't always carry empirical meaning, even when logically valid. He warns against equating syntactic truth with epistemic value. Why? Because math operates within closed systems, while life, cognition, and evolution are open-ended and context-dependent. A model can be correct in form, and yet completely blind to what matters in practice. Key insight number 3, models as generators. Kampis shifts the discussion from models as representations to models as generators. They don't just predict, they construct realities, selectively shaping the kinds of questions we can ask. He outlines a hierarchy. At the bottom, descriptive models tied to fixed structures. Above them, constructive models which produce both structure and content. And finally, self-modifying systems which co-evolve with what they model. This is where the radical turn begins. If we want to model living systems, we need models that themselves can evolve, not just through changing values, but through changing what counts as a value in the first place. The takeaway. Chapter 2 is where the philosophical depth of this book really shows its teeth. Kampis's claim is not just that science needs better models. It's that modeling is the very act of knowing, and we've barely scratched the surface of what that means. If reality is not a fixed map but a moving, branching landscape, then models must be adaptive, creative, and capable of surprise, just like the systems they try to understand. That wraps up this episode of DeepVisus. Next time, we venture deeper into the architecture of complexity, looking at how information is born, not transferred, but generated within living and cognitive systems. Until then, stay sharp, stay curious. And remember, sometimes it's the model that teaches the modeler. DeepVisus, where vision meets depth.